My name is Allam Mangadhar. I am studying BTech third year from NIT Andhra Pradesh. In this video presentation, I would like to explain about genetic algorithm in Python. What is meant by genetic algorithm? Genetic algorithm is an optimization algorithm that are inspired from natural process of natural selection. They are frequently used to solve optimization and generate high quality of solutions through use of biologically inspired operators. What is the basic idea behind usage of genetic algorithm? It is used to generate population of potential solutions for a problem and then evolve that population over successive generations using fitness functions to evaluate the quality of each solutions and genetic algorithms such as crossover and mutation to create new solutions. In this genetic algorithm, we have basic theme: survival of the fittest. This means the population which have high fitness value will survive. The population with low fitness will move on. Basic terminology used in this algorithm: population. What does population mean? Population is a subset of all possible solutions to a given problem. When a given problem, in the given problem, the subset of all possible solutions is known as population. Chromosomes. A chromosome is one such solution to the given problem. This means when a population is converted into some binary or something, when a number is given, that number is converted into a binary code, then that binary code will be known as chromosome. What is gene? A gene is a element in chromosome. What is crossover? One parent is selected and one or more offsprings are produced using the genetic material of the parents. This means two parents are selected using crossover. We will regenerate new solutions. This is known as crossover operator. Mutation. What does mutation mean? It is used to maintain and introduce diversity in the genetic algorithm, genetic population. This will introduce new solutions and maintain diversity. What are the steps used in this algorithm? First one, initialization. Generate an initial population of potential solutions. When a problem is given, we should select the population when we select initial population. From those, we will select fittest individuals from the population. We will select fittest ones from the given selected ones. Crossover. Create new individuals by combining genes of the selected individuals. Mutation. Randomly alter some of the genes in the newly created individuals. Evolution. Evaluation is the fitness of the new individual. Replacement. Replace some of the members of the population with the new individuals. This means new population with the higher fitness will be replaced in place of population with less fitness values. Termination. Stop the algorithm if a satisfactory solution has been found or if certain number of generations have been reached. This means we need to stop the algorithm if we get a satisfactory solution or the number of generations have been reached. Let me take an example with fitness function, a quadratic function, x square minus 4x plus 3. Using genetic algorithm, find the value of x at which fitness value becomes the maximum. First, we need to define fitness functions. Later, we will select few populations, that means few x values. Define selection function for parent selection, which consists three parameters. They are population, number of parents and fitness. Parents in the population are arranged in the increasing order of probability. Probability can be computed as ratio of absolute fitness to the sum of absolute fitness values. Defining crossover function and mutation function. Defining genetic algorithm. Create initial population and iterate through generations. Evaluate fitness of the population and get best genome of the generations. Perform selection of parents and reproduce new offsprings. Replace the old population with new offsprings. Evaluate best fitness of each generation. Repeat the process until the generations are completed. Print the evolution of best fitness and plot the best fitness graph. Let us see the graph for this one. See, from here we define fitness function, defined initial population, defining selection function, crossover function, mutation function and genetic function. Finally, we will get a plot with best fitness, that is generation versus fitness. We will get an output like this. Let us see next example. Find the global minimum of the banana function using genetic algorithm with most efficient and effective parameter settings. Banana function. What is banana function means? f of x y, f of x comma y equal to 1 minus x square plus 100 y minus x square whole square. How do we approach the problem? Defining initial fitness function. As we know, banana function This will be the fitness value, fitness function. As the this is a minimization problem. We will take negative sign to the function and convert the problem to the maximization one. Next, we will define genetic parameters such as population size, number of parents, and number of generations, mutation rate. Initializing populations, initialize lists to store best fitness and solutions. After this, we will iterate through generations and evaluate best fitness value of each generations. Select the parents with high fitness value and move them to a list. Create a list which is named as offspring. Select two parents from the list at random. Reproduce new offsprings from the selected parents. Append the newly obtained offsprings to offspring list. Replace new old population with new population, new offsprings. Store the best fitness and solutions. After all iterations, print the best fitness and solutions till the last generation. Evaluate, print the evaluation of best fitness and plot the best fitness graph. Let's say code for it. First, first of all, we will define fitness function, fitness of x comma y. In return, here we will take minus sign. As this problem is a minimization one, we will multiply this with a negative sign to convert this one to a maximization problem. Later, we will initialize population. Next, initial best fitness and solutions. Iterate through generations, creating new offsprings, selecting two parents. Now, let's see the output for this code. Here, the population size is taken 10 and number of parents are 20, number of generations are 10 and mutation rate is 0.01. For these parameters, I got plot like this: fitness versus generations. Applications. Using genetic algorithm, we can optimize R1, R2 in voltage divider circuit. The goal of this optimization is to find R1 and R2 and produce output voltage is calculated that is as close as the possible to desired output voltage. The genetic algorithm starts with a randomly generated population with potential solutions, each represented by a pair of values for R1 and R2. And the fitness of each solution is evaluated by computing the absolute difference between the calculated output voltage and desired output voltage. Lower the fitness scores indicate better solutions. The algorithm then selects pair of parent solutions based on their fitness scores and produce offsprings through crossover and mutations. Crossover involves combining some genetic material from both parents and to create new solutions, while mutation involves introducing new small random changes to genetic material of an existing solution. New offspring solutions are evaluated using a fitness function, and the process of selection, crossover, and mutation is repeated for fixed number of generations. At the end of evolution loop, the solution with the lowest fitness score is chosen as the best, and corresponding resistor values are outputted as optimized values of R1 and R2 in voltage divider circuit. Let's see the code for this. In this, we have to define, like, we will give initial guess for input voltage, output voltage, and R1 and R2, which means we will give input voltage and desired output voltage, and we will give initial guess for R1 and R2 resistors. Defining fitness function. Fitness function is defined here. V output calculated is equal to Vn into R2 by R1 plus R2. Fitness function. It is the absolute difference between output calculated by minus V output desired. This will be our fitness function. Here we will define genetic parameters like population size, number of generations, mutation rate. After that, we will initialize population and evolution loop. At the end of, we will give an input voltage as 5 and output voltage 2.5. Initial values for R1 and R2 100 and 100. Population size 10. Number of generations 10. Mutation rate 0.01. When we keep this, we will get like this. Fitness will be 0.01, 0.1050. Best solution means the combination of R1 and R2. This 62, will be our desired resistor values. This means optimized values of R1 and R2 are 62, 62. Thank you.